Section number 45 is entitled Graphing Inequalities. This of course is an equality symbol or an equal sign. This is an inequality less than or equal. This is just strictly less than. This is the inequality greater than equal to and greater than. You have four inequalities. And we want to graph inequalities. They're lines, but they don't have an equal sign. Suppose you wanted to graph y is less than or equal to 3x plus 2. That's the instructions. Graph this. Graph that inequality. Well, first, you graph the equality. Y equals 3x plus 2. And we'll get a few points. Well, okay. We'll use the point slope formula or technique. Since this y is equal to, that's m, which is 3 over 1, and that's the y-intercept. The y-intercept is 2. Okay. So, I go to my y-intercept, which is 2, right here. That's my point. And this time we'll do a little bit different. If the y-intercept is 2, that means 0, 2. So 3 is the change in y. You add 3 to the y. And 1 is the change in x, so you add 1 to x. And 0 plus 1 is 1, 2 plus 3 is 5. That gives me another point. 2, 1, 5. 1, 3, 4, 5. Right here. Again, if you started at 2 and you went up 3 and 1 to the right, you'd end up at the same point. So these 2 points will determine the line. Now, sometimes you dash the line. Sometimes you draw a solid line. And it depends upon whether or not it says equal. If it says equal, you draw the line. Remember, if this y is less than or equal to 3x plus 2, this means one of two things. Y is equal to 3x plus 2. Hence, the solid line. That's how you always graph a line. Or, y is just less than 3x plus 2. Now, if it didn't have the equal sign, then you would just have that y is, that is this. I know I'm repeating myself, but this means just this. It doesn't mean y can equal 3x plus 2. So there's no point in highlighting y, the line y equals 3x plus 2, because you're not allowed to equal that anyways. Okay. If it says equal in the inequality, remember the 4 symbols I just drew, or I wrote, some of them say equal. If you have less than or equal to, or greater than or equal to, it should be a solid line. If it's just less than or greater than, you should draw a dashed line. Okay. Now I want to draw this line just a little bit longer. We'll draw the line a little bit longer. This line separated the whiteboard into 2 regions. Top left of the line, bottom right, below and to the right of the line, above and to the left of the line, and below and to the right of the line. Now, either the final answer will include all the points over here, or all the points up here. One of them and only one of them is correct. So we need to decide which one is correct. And rather than erasing both of them and putting one back, let me find out which one is wrong. So we want to pick a point that we know which half of the line it's on. And it's pretty clear to me which half of the line the origin is on. So we're going to test the origin. We are going to test the origin, 0, 0. Again, either it's all of these points and none of the points up here, or it's all of the points up here, but none of the points down there. So if 0, 0 is part of the answer, then I'll keep everything down here and erase everything above. If 0, 0 is not an answer, well then you better believe I'm going to erase everything down here and keep everything on top. And how do we test it? We go back to the original inequality. Whenever I say or see x, I'm going to write 0. Whenever I say or see y, I'm going to write 0. Is y less than or equal to 3 times x plus 2? Is 0 less than or equal to 0 plus 2? Is 0 less than or equal to 2? And the answer is yes it is. Yes it is. So 0, 0 we keep. That is, we keep all the points down here. We keep all the points down here, and to the best of my ability, I will erase the points above it. All of these points, they get erased. And if I leave a little bit, understand they're not there, please. I left a lot. Okay, so there's the answer. Everything on the line and below. So you draw the line and then you shade in 1/2 of that line. Either above or below. And you decide by picking a test point. Suppose you are asked to graph 3x plus 4y is bigger than 12. Since it's not equal to, when I draw the line, it will be a dashed line. So first we want to graph 3x plus 4y equals 12. So if x is 0, it says if this is not here, positive 4 times y is 12, y is 3. Remember that's how we did that? And if you want, you can draw that. Then you let y be 0, which means this is not here. And 3 times x is 12, x is 4. Now I have the graph, or I have 2 points on the graph, which in my mind tells me I have the graph. It crosses at 0, 3. That means it crosses the y-axis at 3. And 4, 0 means it crosses the x-axis at 4. Now, here's the line, but I'm going to dash it. Again, it's a dashed line because it doesn't say greater than equal. It just says greater than. Just says greater than. Okay. Now, which half do I shade in? So, we test the point that we know which half of the line is on. 0, 0, I know what half it's on. The only time I wouldn't use 0, 0 is if 0, 0 was on the line. Then it's not on 1/2 or the other. It's on the line. Okay, now, x is 0, y is 0. I rewrite this equation, or inequality, and instead of x and y, I put 0 for x and 0 for y. It's 3 times x plus 4 times y bigger than 12. Is that true? Is 0 plus 0 bigger than 12? 0 plus 0 is 0. Is that bigger than 12? Of course not. So I don't shade in the area that has the origin, 0, 0. That is, I shade the other half. And there is your answer. There is the graph of the inequality 3x plus 4y is greater than 12. Let's do some more. I would always test 0, 0 if I were you, except if it's on the line. Because if it's on the line, then it won't be above or below. We won't know which half to shade in. Suppose you wanted to graph y is greater than or equal to negative 2x. So first you graph y equals 2x. And since it does say equal, would be a solid line. Now, there's a couple of ways of doing this. You can realize that we're adding 0. So y equals mx plus b is 2. Plus b is 0. So we know that we cross the y-axis at 0. That is known as the origin. And we know that the slope is 2. So you can take 0, 0, and the slope 2 is the same as 2 over 1. That is, you add 2 to the y, and you add 1 to the x, and you get another point. You get the point 1, 2. So there's another point. And since it does say equal, I draw a solid line. And now I need to decide which half to shade in. Well, 0, 0 is going to pass the test. Is 0 greater than or equal to negative 2 times 0, which is 0? Is 0 greater than or equal to 0? Yes, it is. Which half do I shade in then? Oh, the half that has 0. But 0 is on the line. 0, 0 is on the line. So we need to test another point. We need to test another point. You can say 5, 0 right here. Let's test 5, 0. X is 5, y is 0. So I want to write y is greater than or equal to negative 2x, but I want to use those values. Y is 0, greater than negative 2 times x. 0 is greater than negative 10. And yes, 0 is bigger than negative 10. So we include the region that contains 5, 0. That is, we shade this way. And that graph is done. That graph is done. In intermediate algebra, you're going to be given 2 of these inequalities. And you want to see which region satisfies both of these equations or inequalities. If you needed to graph y is greater than 7, to be honest, I would hope that you can do that without really going through everything we've been going through. Here is where y is 7. Every point below y is less than 7. And I know it is, because when I look to the y-axis, I'm getting numbers below 7. These y values are all below 7. And everything up here the y values, y, they are above 7. Which means, here's the answer. These are all the points where y's are bigger than 7. Okay, make believe the graph isn't there. Make believe the graph isn't there. So let's do this the long way. If you're asked to graph y is bigger than 7, first you should graph y equals 7. And since it doesn't say equal, you draw a dotted line. And y equals 7, you're going to have to know it's this line right here. So now we have the line, so we have to test. We have to run our test to see which half we shade in. 0, 0 is below the line. Let's test 0, 0. Wherever I see x, if I see x, I put 0. Wherever I see y, even if I don't, if I see y, I put 0. If I don't see y, I don't put 0 for y. Is y bigger than 7? No. Don't shade in the half that has 0, 0. So shade the other way. And there's your graph, something that we had a few minutes ago. There's your graph. If for some reason you don't like 0, 0, well then test another point. But you need to know what half of the line it's on. Last one. X is less than or equal to negative 2. Well, if you graph x equals negative 2, well, you go to negative 2 and it goes straight up and down. Since it says equal, I'll draw it straight up and down as a solid line. A very straight line. And then you have to decide, do I shade to the left of that line or to the right? Well, if you want the x's to be less than negative 2, you really should shade here. You should just see that. These x values are all less than negative 2. But if you needed to test, I would test the origin. Should I include that point? And if yes, then I will include all of these points. Then I would include all of those points. X is 0. Is 0 less than or equal to negative 2? Yes, it is. No, it isn't. It isn't. 0 is not less than negative 2. That's why I don't shade in where you see the dotted lines. I shade in the other half. And there's the answer. On that note, that completes the section entitled Graphing Inequalities. Good luck with that.